For the Module 9 quiz review, we're going to go over our transformations we discussed. So translations, reflections, rotations, and dilations. So in problem 1, we are going to write the translation rule both as a rule and in vector form. Then we want to draw the vector that represents the transformation from A to A prime. So we look, says our translation is 5 units to the right, 4 units up. So we look at our point A, we want to go 5 units right, then we want to go 4 units up to place our point A prime. So I'm going to write the rule for my translation. The direction we moved right and up represents the change in our x and y coordinates. So our x coordinate got increased by 5 because that was 5 to the right, and then our y coordinate increased by 4 because it went 4 up. Remember, when we write a rule for a vector, we just care about the values because the vector is drawn as a direction. So my vector is the vector 5, 4, since that's the change in our values. And if I were drawing the vector, I would just draw the partial arrow in the direction that it traveled. In problem 2, we want to find the coordinates and graph the vertices of the image A, B, C, D for our transformation. So we look down below, we have the translation rule, x plus 4, y minus 3. So the first thing I want to do are find my new points. So I'm going to first write the points of A, B, C, D, my original figure. So A is at the point 0, 3. B is at the point negative 4, 0. C is at the point negative 6, 4. And D is at the point negative 3, 5. Now I can apply my rule to each of those points, which is to add 4 to x and subtract 3 from y. So my new point A prime, 0 plus 4 is 4, and 3 minus 3 is 0. B prime, negative 4 plus 4 is 0, and 0 minus 3 is negative 3. For C prime, negative 6 plus 4 is negative 2, and 4 minus 3 is 1. And for D prime, negative 3 plus 4 is 1, and 5 minus 3 is 2. So now I can plot these points, and I will have my new transformed figure. So 4, 0, for A prime, 0, negative 3 for B prime, C is at negative 2, 1, and D prime is at 1, 2. So I connect my 4 points, and we get the same image, just translated. Our next 2 examples have to do with our reflections. So in problem 3, we want to reflect over the y-axis. So the y-axis is the one that goes up and down. So to reflect a point over the y-axis, we just count the distance each point is from that line and make sure we go the same distance. So we start with A, it's on the y-axis. So our point A prime is actually going to be in the same place. B is 4 spaces away from our y-axis, so then we move 4 spaces on the other side to get B prime. C is at 6 spaces, so we move 6 spaces to get C prime. And D prime is 3 spaces away, so we move 3 spaces to get D prime. So if we connect those 4 points, we get our reflected image. Okay. And then also we want to label our new points. So A prime stayed in the same place, which is 0, negative 4. B prime is now at 4, 0. C prime is now at 6, negative 3. And D prime is now at 3, negative 2. So remember, the rule for reflecting over the y-axis is our point xy we do the opposite of x and we keep y the same, which is exactly what happened here. Realized A is not, sorry, never mind, that was correct. So problem 4, we want to reflect over the x-axis. So our x-axis goes straight across. So similar to the previous problem, my first point I is actually going to stay there. L is 3 spaces away, so we go up 3 to get L prime. J is also 3 spaces away, so we go up 3. And K prime is 6 spaces away, so we go up 6. So connect our 4 points, and we get our new image. So I'm going to write the coordinates of my point. I prime stayed the same. It's at -2, 0. J prime is now at -1, 3. K prime is at -2, 6. And L prime is at -6, 3. So remember, the rule for a reflection over the x-axis is our point xy. We keep x the same, but we make y its opposite, which is exactly what we did in this example. Now we want to follow our rules for rotations. And remember, the general rotation is always counterclockwise, and if we want to move in a clockwise direction, we have to signify that. Our first example is a rotation of 270 degrees counterclockwise, and I've included the rule here for you. It tells you how you have to transform your point. I'm going to find our new points first, and then we'll go ahead and graph it. So let's start by listing our original point. So the point A is at -3, -3. B is at -2, -1. And C is at -1, -4. So if we look at the rule for a 270 degree counterclock rotation, we switch x and y and then make the original x its opposite sign. So when I switch the points -3, -3, it's going to become -3, 3, because we keep the original y value the same and make x its opposite. B prime, -2, -1, it's going to become -1, 2. And C prime, -1, -4, is going to become -4, 1. So now when I plot these points, -3, 3 is A prime. B prime is at -1, 2. And C prime is at -4, 1. So we have our new triangle that has been rotated 270 degrees counterclockwise. And remember, a 270 degree counterclock rotation is the same thing as a 90 degree clockwise rotation. Our next example is the rotation of 180 degrees. Now, 180 degrees, we don't have to signify whether or not it's clockwise or counterclockwise, because 180 degrees is the same in either direction. So I'm going to start off by listing my original points. So A is at -1, -2. B is at 0, 1. And C is at 1, -1. The rule for a 180 degree rotation is to make x and y their opposite signs. So the opposite of -1, -2 is going to become 1, 2 for A prime. The opposite of 0, 1 is going to become 0, -1. And the opposite of 1, -1 is going to become -1, 1. So now when I plot my new points, A prime is going to be at 1, 2. B prime is going to be at 0, -1. And C prime is going to be at -1, 1. Connect our 3 points, and we have our new triangle. Now we're going to talk about dilations. So a dilation is when we multiply the coordinates by some scale factor, k, to make our image either bigger or smaller. Our first example, we have a dilation about the origin with a scale factor of 4. We start off with our original triangle pi at 1, 2, 3, 1, and -1, -1. And then the rule has been written for us. So a scale factor of 4 is the rule xy to 4x, 4y. So I'm going to start by graphing my original triangle. So P is at 1, 2, I is at 3, 1, and E, which is at -1, -1. I'm just going to rewrite these points in my parentheses here. Now when I apply the dilation of 4, I'm going to multiply each coordinate by 4. So 1, 2, when I multiply that coordinate by 4, we get 4, 8. When we multiply the coordinate 3, 1 by 4, we get 12, 4. And we multiply the coordinates -1, -1 by 4, we get -4, -4. So now my new image, P is now at 4, 8, so P prime. I is at 12, 4, we got I prime. And E prime is at -4, -4. Then we can connect our coordinates. And we have our dilated triangle, which has been enlarged. So remember, k greater than 1 is an enlargement, which is obvious because our triangle has gotten larger. Our second example, we want to dilate about the origin with a scale factor of 3/4. So our rule has been written for us. So again, I'm going to start by graphing our triangle BAT at -4, 4 for B, 12, 4 for A, and -8, -4 for T. We're going to transfer those points to our parentheses. So -4, 4, 12, 4, and -8, -4. Now there are a couple ways you can multiply by fractions. You can multiply each coordinate by the numerator first, then divide by the denominator, or you can go the opposite route. You can divide by the denominator first, then multiply by the numerator. And I'm going to go that second route. So -4, 4, when I multiply it by 3/4, I'm going to do -4 divided by 4, which is -1, then times 3, and I'm going to get -3. When I take 4 and do the same thing, we're going to do 4 divided by 4, which is 1, times 3, which is going to give us 3. 12, 4. 12 divided by 4 is 3. 3 times 3 is 9. And then 4 times 3/4 is going to be 3. -8 divided by 4 is 2. And -2 times 3 is -6. And then -4 times 3/4, we already know, is -3. So my new coordinates, let's first connect the coordinates of the original triangle. So now my new triangle, -3, 3 for B prime. A prime is at 9, 3. And T prime at -6, -3. Connect our 3 points. So just a reminder, anytime your scale factor k is a fraction between 0 and 1, we have a reduction where our image gets smaller, which is again obvious here because our original triangle, which was black, became smaller to give us our new triangle in blue. Next, we're going to talk about writing a rule to describe a transformation. So first you have to determine what type of transformation you have, whether it's a translation, rotation, reflection, or dilation. It's only going to be one of the three, and you have to go based on first size. If they have stayed the same size, it's not a dilation. Then you have to figure out between the other three. Have you rotated it? Have you flipped it? Has it slid in some way? So in number 9, it's obvious to go from triangle ABC to triangle A prime, B prime, C prime. We have a reduction. And when it's a reduction, that means we have a dilation. So we have to figure by what scale factor K our triangle has been dilated. So to figure that out, we pick 1 point from our original triangle and 1 point from the new, and we put them over each other to get our scale factor. So I'm going to pick the point A prime. I'm going to pick the point B prime. And I'm going to put it over its original point B. And you only have to pick one value from each of these points. I'm going to choose the X value from each of these points to compare to figure out what my scale factor is. So B prime has the X coordinate of 2, and our original point B has an X value of 8. 2 over 8 is 1/4. So we have a reduction of 1/4. So when I write my rule, XY, I'm going to put 1/4 X, comma 1/4 Y. Because we have our scale factor, what we have to multiply each value by to get our new point. In number 10, if I'm looking at my two quadrilaterals, they have stayed the same size, so it's not a dilation. I haven't flipped it over a single line, so it's not a reflection. It actually looks like if I've turned my point. So in this case, we have a turn, which you can think of as a rotation. So we pick 1 point from the original and 1 point from our new quadrilateral to figure out what type of rotation we have. So I'm going to use point T. So the original point T is at 3, -2, and my new point T prime is at -2, -3. So we want to look through our rotation rules and figure out what rotation we have. So first thing, we've switched X and Y. So it can't be a 180-degree rotation because that one doesn't involve switching Y. So if I'm looking at my rule, I've switched X and Y and I made the original X its opposite sign. So if I'm looking at writing the rule, Y is going to come first. And then we're going to have -X, which represents making X its opposite sign. So last examples, we're going to write some more rules. So we look at number 11. It has stayed the same size, so it's not a dilation. I haven't translated it at all. I haven't slid it, anything. I haven't turned it. This is where I flipped it. So a flip, if you remember, is a reflection. So you need to find the middle of this reflection so you can figure out what the rule is. So you have to count the distance between 1 point and find its halfway. So to go from A to A prime, that's 1, 2, 3, 4, it's a distance of 4 units, and half of 4 is 2. So if I go 2 units between either two, that gives me our line of reflection. And if I'm looking, my line of reflection, in this case, is the y-axis. And when we reflect across the y-axis, we make X its opposite sign, and we keep Y the same. If I'm looking from A to A prime, A went from -2, 1 to 2, 1. So Y stayed the same, but X got its opposite sign. Number 12, we have our two triangles. If I'm looking, I have slid my triangle, so a slide, which is the same thing as a translation. So in order to identify the rule that describes this translation, I need to pick an original point and its corresponding point, and I'm going to pick point Q. So point Q is originally at 5, -2, and its new point Q prime is at -2, 4. So I need to figure out what I need to add or subtract to each coordinate to get my rule. So to go for my x value, 5 to -2, I need to take my x value and I need to subtract 7. For my y value, to go from -2 to 4, I need to take y and add 6. If I double check, 5 minus 7 is -2, and -2 plus 6 is 4. Last example, which it's kind of given to you what we have for our reflection here, is because we've drawn the line y equals x, and we've taken our original octagon and reflected it over to get the new. So when you reflect across the line y equals x, you just switch x and y. So it's become y comma x. Again, make sure you have all of the rules filled out in your notes from each of the 3 sections. So for translations, rotations, reflections, and dilations. They should all be either given to you already in your notes, or you should have copied them down by watching them on Edpuzzle. So make sure you go through those once over before we take the quiz. And if you have any questions, please email me or send me a message on Remind.